Yeah, so the reason why we want to avoid mold, there's pretty much two, like maybe even three, I would say. So one is obviously the health reason, like it's
Yeah.
unhealthy. You don't know what you're growing there, what type of mold, black mold, or like what's the health impact for the people in there. Second one is the impact to the structure, because it can have a structural impact and can reduce the lifetime of our building. And third is as well a visual, like it looks ugly. Hello, Julia. Good to see you. How is Germany?
Hi, Daniel. Yeah, I'm currently in Germany. Germany is great. It's always good to be back. It's it's a good place to be. The weather is, I thought it's similar to where I live in Australia, to Perth. Yeah, so currently we have about 20 degrees during the day and about 5-6 degrees at night. But the biggest difference is that I'm not cold here. So I slept at my sister's house where I'm currently in, and at night I'm even too warm, which never
Hmm.
happens in Australia.
Yeah, yeah, yeah,
And yeah,
yeah.
obviously that happens because buildings are built very differently. Yeah, it's amazing what building quality can do.
Mm,
So as I said, it's outside is not much warmer, but
mm,
inside it feels completely cozy. Yeah, and it's always interesting to look at the houses.
mm,
So two things that always jump at me is how thick the walls are. So obviously we have a colder climate, so obviously the walls are thicker than in Australia. But I see those big window reveals where sometimes, you can even sit in the window sill inside. So that's
mm,
always what jumps into my eye. And the other
mm,
thing that jumps into my eye is my sister lives in a good area, and every window looks the same. Yeah, so
mm.
everyone has white UPVC windows. It doesn't matter if it's a villa like for really rich people or if it's a normal, sort of attached house. All
Mm.
the window frames are white UPVC. Obviously, they're double or triple glazed, but there's not a big difference between them. They're not going
Yeah,
all out and yeah.
yeah, that's what I find here in Australia is so crazy. Everybody's putting so much fuss about, oh, we can't use UPVC windows. We need to use aluminum windows. Oh no, they're slimmer and they look nicer. But at the end, they look so ugly. Like, in my opinion, they're so ugly. These aluminum frames, like harsh corners. They're
Mhm.
not fitting. They're making strange noises when you move them. Yeah, like for me, I don't understand that hype around the aluminum frames. They're just, yeah, horrible from a performance. In my opinion, they're looking really bad as well. And the noise as well from this metal on metal,
Oh yeah,
yeah, it's like a little bit
screeching.
like chalk on a board. But yeah, everybody has their own interests, own favorites, and maybe what you've grown up with is the one thing that
Yeah,
makes a
maybe.
difference. Yeah. So what's
What
the
I
biggest
also find
difference? Yeah, what's the biggest difference you've seen but between Germany and Australia? What's the contrast like coming from Australia to Germany?
Yeah, as I said, yeah, it's the living situation. Obviously, a lot more life happens inside, yeah, because
Mm,
it's now it's been raining for the last 2 days, and it's a constant rain. There's no like there's no break, so the whole day, and life is much more inside. But the inside is a lot more. It's nice to be inside, yeah. So if
mm,
it's like the other day, I thought, oh, it's a bit noisy from outside. I can't remember what it was. It was a car or a siren or something, and I just closed the window, and it was
mm,
silent, and
mm,
that's
mm,
not
mm,
something
mm.
you're used to in Australia.
Yeah.
So it's a very different feeling of
Mm,
people are happy inside. I have the feeling that Australians are they want to be outside a lot more, and that's
mm.
also understandable. But here people are very content in their homes and they're very comfy.
Yeah, as well, I find especially the German houses, there is a lot logic to it. Like your
Hmm.
robe at the entrance of your house, you're coming in,
Yes,
and that is normally always a place where you can put your coat, where you can put your shoes, where
yes,
your guests can put their stuff as well. And often you
absolutely.
as well have a toilet before you actually coming into the house, really. Like you often have this separation of like a foyer style where you don't
Yes,
really need to go into the house to actually go to the loo. That's something I've noticed a lot as well. Yeah.
totally. This entrance area that you mentioned is
Mm,
very typical because obviously, if it's wet, if there's snow for like a long time in the winter, you don't want to bring all that mud and dirt inside. So there's
yeah.
always an area where you leave your shoes and you always go inside without shoes.
Yeah.
And then there's piles of shoes, big piles of shoes and wet shoes and
Yeah.
umbrellas and raincoats. You have to hang them
Yeah.
somewhere. You don't want to bring them inside and hang them in your house. So there's always that. And it makes sense. Yeah. So there's a
Yeah.
lot of this. And the other difference I feel is that the design is often very clever because houses are generally smaller. Yeah, we don't have so much space here, and people don't live in 200 square meter homes, more like 100 or 150 maybe, if
Mm,
that's big. And spaces are used very cleverly. Yeah, so we
mm,
have like space under the stairs is used for storage, or even sometimes there's a toilet under the stairs that just fits, and you just sort of go in, and it's just enough room, but it works. And
mm,
that obviously makes the building envelope smaller and
mm,
a bit more compact. Often it's double story. That also happens a lot more often than in Australia
mm,
because, land is a bit more scarce and they have to
mm.
build up to make the size.
Yeah, but as well, two-story is always more compact than a single story. And as well,
Yes.
it's cheaper. It's cheaper. You need half the
Mm,
concrete slab and half the roof. Yeah. So like you're saving a lot of money. That fuss about no, two-story is more expensive doesn't really make sense in that I see here in Australia. Everybody says two-story is more expensive, but in reality it's not. And it's actually cheaper to run because it's more compact. And because it's more compact, you're actually achieving higher performances with less work. Yeah. So
exactly.
that's the whole passive house idea, but I'm going a little bit far here already. So let's jump into the article today. What's the article about today?
Yes, and I think it's a good one leading on from these differences. This week we're talking about why a cold spot is a mold spot, and
Hmm.
we're talking about the building physics that's behind that and that you should know because
Hmm.
it's really interesting. Last time we explored that Passivhaus doesn't have to be expensive, but today we want to talk about this health, like really important topic for our health.
Hmm.
And we're seeing that a lot of houses in Australia, and I've read an article a while ago that even schools and things like that, they do have mold. And that's obviously very bad for you.
Yeah. So the reason why we want to avoid mold, there's pretty much two, like maybe even
Hmm.
three, I would say. So
Hmm.
one is obviously the health reason, like it's
Yeah,
unhealthy. You don't know what you're growing there, what type of mold, black mold, or like what's the health impact for the people in there. Second one is the impact to the structure, because it can have a structural impact and can reduce the lifetime of our building. And third is as well a visual, like it looks ugly. Like it looks
hmm
as well really ugly. So it's as well from an aesthetic perspective that you don't really want to have it. And I always as well like don't know, but my nose is so sensible to mold. I really
hmm
smell it so fast. It's like there's mold. Yeah, it's like it's always it's
you're like one of those dogs at the
yes,
airport that can
yeah,
sniff
exactly,
out.
yeah, for mold.
Yeah.
So what's the relation between cold and mold? Why is a
Mhm.
cold spot a mold spot?
Yes. So look, when we notice mold, or maybe you have noticed that as well, that often it creeps in around corners and around the windows, where where the frame meets the glazing. At that
Mm,
edge, there's often mold. And we need to understand what's really happening. And we then want to sort of go into why Passive House eliminates this problem.
mhm.
Obviously, what's what we want to explain. The reason why those corners are mold spots is because they're thermal bridges.
Yeah, the thermal bridges. So I would actually start with cylinder.
Mhm.
With our beer cans we're getting out of our
Yes.
fridge, yeah, or everything we're taking out of the fridge and we put it on a desk, then we have condensation on them because it's a cold surface, and then when the cold surface is attracting the air is cooling down as well, and now the absolute moisture content stays obviously the same, but the relative moisture content goes up to 100%, and then you have condensation. Yeah, and that's the reason why we have that condensation on our stuff that comes out of the fridge. And a similar thing is happening in our corners, that our corners are getting colder because there are a thermal bridge because of the shape of it. In the article, you will see as well like the shape of a wall, and you see that there is a cut through the wall. And when you think about it, on the inside of the corner, there is a really short distance, and on the outside of the corner, there's a really long long distance, and this distances are the areas where the temperature from that area are now competing with the other side. So this huge area is competing with this small area. And that's the reason when outside it's cold, it goes now in, and that corner gets cold as well. That's the reason during winter we're getting mold problems in that area. What means these areas are colder, these areas are temperatures are dropping down, but we normally don't see condensation in that corners. Why do we actually have mold in there, but we don't see condensation? We see it on windows, but we don't see it in the corners.
Yes, that's right, Daniel. That's because the physics behind it is a little bit different. We can already get mold growths at 80% relative humidity, which means that we're not seeing condensation yet, but there's enough moisture in the air that the mold says, I like it here. Yeah, mold needs a few things to grow. Yeah, it needs the spores, it needs a temperature that it likes, and it needs the moisture. And when we have these
And what does it need as
things
well?
given,
What does it need as well? Food. It needs food.
yeah, I forgot that.
Yeah,
That's right, Daniel. Exactly.
yeah, yeah, yeah. So the
So a bit of
environment needs
dust
to
or a bit
grow.
of something.
Yeah, yeah, and
Exactly.
we can't get rid of the food.
No,
We can't really get rid of temperatures, like we can control them, but
yeah,
moisture is the one that we definitely can get rid of,
that we
and
can
that's
control. Exactly.
what we are trying to do with our thermal bridge-free design. Um, so let's put that a little bit into temperatures, because 80% of relative
Yep.
humidity, you can't see it. You can't, like most people
No.
can't have not a measurement tool for relative humidity at home. You can get a sensor, but it's not on the surfaces then in your room. So the surface temperature, when it drops to 13 degrees, around that temperature, then we're already having 80%. When it drops down to 10 degrees, then we're having the 100%, and then we have our condensation in a normal condition. In your bedroom, you probably noticed that as well. If you have your bedroom door closed and you're sleeping in there with 1, 2, 3, 4 people, then your windows often have a condensation while the others don't. The reason is your evaporation over the night. You're sweating, you're losing moisture from your physical body, and that's the reason why the relative humidity goes up, and that means the condensation happens earlier, not at 10
Earlier.
degrees, but maybe at 12, 13, 14, and then the whole water is actually running down on your windows and on your reveals and everywhere as well. The chances of mold are far higher because your moisture content is higher. So the risk of mold in bedrooms, where we're spending the most time of our life in, of all the rooms, it's the bedroom. That's the place that we can have easiest mold growth. That's the risky thing, that the bedroom is the highest risk place for mold in a house because of that evaporation, and we're spending so much time in there as well. Like our breath is transporting moisture as well. So as well, if you weigh before you go to bed and you weigh when you're going getting up in the next morning, you're losing a half a kilo. Yeah,
Yeah.
even if you're not
Water.
going to the bathroom. Yes, some people go to the bathroom during the night, but even then, yeah, and that half a kilo had to go somewhere. Some is in your mattress, in your blanket. Sounds a bit disgusting, but as well in the air. So that's what is happening. So where we at in the article?
So we said that we can control the temperature and that the
Mhm.
temperature has something to do with that cold spot, mold spot, and with the relative humidity. So maybe we should go into why or how Passivhaus controls that temperature and makes a difference in the mold growth.
Okay, so that is now the thermal bridge free design. So we're making sure that the energy going through that corner is less than 0.01 watt per meter Kelvin if you're speaking linear, and watt Kelvin if you're speaking point. Julia knows this
Yeah.
number far better because she's teaching it now. That's memory from a few years back. And
Yeah.
what does this actually mean, watt per Kelvin or watt per meter Kelvin? Can you explain that, Julia?
So it's the amount of energy that's going through if we're looking like at a square meter of wall, it's the amount of energy that's going through there. If there's a temperature difference between the two sides, obviously there has to be a temperature difference. And if we're talking about thermal bridges, we have different kinds of thermal bridges. As Daniel mentioned, the watts per Kelvin is the point thermal bridge, so where we just have it at one point. So this could be a penetration or something like that, a nail, a screw. Prominent ones are probably the linear thermal bridges. So where we're looking at like a corner, yeah, that's a whole corner that could be over a few meters, or where you have your window, that's also like the whole window where we're measuring it in meters, and that's where most of the time that becomes very prominent in that, and that's the energy going through there over the distance.
So understanding that a little bit is, if you think about, you have a split system, and that split system is now providing you heat, yeah, and that has as well energy. We had to lift that cold energy to a warmer energy, and that is energy, yeah, that's the watt, yeah. And when you look on your devices, you normally see the watt. That's how much energy is needed to run this device at the end, yeah. In the way, the size of your engine in a car. That is what the watt is telling you. And then it tells you, okay, here is your energy loss at this constant of watt per Kelvin. And Kelvin is just a thermal difference. Yeah, so Kelvin is
Exactly.
degrees Celsius, and it's just telling you how much energy is going through this structure at 1 degree difference. And now we know we don't have 1 degree difference. We have 10 degrees, 20 degrees, 30 degrees difference. And now we just multiply by that difference, and then we're getting our energy loss. Out of that, we can calculate the temperature on the surface, but as well how much it actually costs us. On the costing side is interesting. What we normally say roughly on the glazing edge of a window, so we're going now a different direction again. On the glazing edge, a linear meter of glazing edge with a spacer that is an aluminum spacer, not a high performing spacer, we normally say €1 per linear meter. So that's about $1.50 in Australia per linear meter. And now calculate how many linear meters you actually have. That's the amount of energy in a year that you're losing through it and that you pay for correcting that temperature. $1.50 per linear meter. If you have 100 of them, you have $150. No, is it? Yeah, $150 of additional cost every single year because of that. So and that numbers you get out of your calculations in the PHPP. What else are we talking about in this article, Julia?
Yeah, so we talked about temperature already. So maybe we need to talk about how does Passivhaus change this? So we said already that we need the surface temperature that can't go below a certain threshold. But how does Passivhaus make sure that we are achieving that? So what is behind that? Maybe we should go into that a little bit.
So
Explain.
Passivhaus is just making sure that we don't have thermal bridges. That's what it at the
Yes.
end is. So we're making sure that we have only 0.01 watt. So that is like, if you want to have an LED light being lit up, yeah, that has normally 8 watts. That would be 800 LED lights per linear meter of energy coming through at 1 degree thermal difference. Yeah, if you now say it's 10, it's 80 80 LED lights. No, 80 meters for 1 LED light. That's the amount of energy that we're designing our impact of that thermal bridge. What is, yeah, like you see already how crazy it is. Like LED needs no energy, and now we actually need 80 meters of linear meters to have the same losses than we would have running through that LED light. And that's the reason we don't have that more problems in cold spots, or like we don't have cold spots in a passive house. We eliminate them by design. They can't be in a passive house because we're designing them in that way. That's the reason why we don't have mold problems because of cold spots. However, is it possible to create mold in a passive house? Yes, there is. So that might be as well good to know. If you're designing a passive house, you are calculating as well the ventilation rate that is needed in a building. And that's depending on the amount of people in there, because every person creates moisture, like I said earlier already. And if the designed use is not the actual use, then we can run into problems. And that happened to one of our students that built himself a passive house. He built actually not a passive house, a retrofit. He built an extension to a building, and he then said, okay, me and my wife, we're actually living in that extension, and the kids, they can stay in the old part of the building.
Ah,
Yeah. And the three kids said, no, 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 we want to live in the new part as well. And now everybody lived in the extension, and now you have everybody using the same shower in that extension. Everybody is living and breathing in there, and the other part is locked off. And now they created more moisture that they started to have a bit of mold problems in there. And all what they had to do is ramp up the ventilation system so that actually they have more ventilation because there are more people in there. And that's the reason why in the ventilation system we have 3 calculations: minimum ventilation per square meter, minimum ventilation by amount of smelly rooms like kitchen, toilets, bathrooms, and the use of people. And in this case, what normally never happens in Australia because the houses are so big, was then coming down that we had to design it to the people and not for the size of the building. Because in Australia, the houses are so big that normally the amount of humans in the space are not the design factor. So, okay, that was a little story. What else
that's
should we
good.
say about it? What else should we speak about in here?
Yeah. So I think it's good that you mentioned that eliminating thermal bridges is the one thing, but good ventilation is another important thing for avoiding mold growth. Maybe we should also go into PHPP because we mentioned PHPP in our last week's
Mhm.
episode, I think, or on the week before, that we said how PHPP can, sort of can make sure that we're designing the right thing. And also
Mhm.
for these thermal bridge free design, PHPP plays an elemental role.
Yeah. Okay. So there's a lot of things to unpack. First of all, in PHPP, we cannot do a thermal bridge analysis. That is external of the PHPP. So we have to use something like a therm, or what's the other one?
Like so.
Flixo, that's the most common one used. So we need to do that externally to actually calculate it because it's such a complex calculation that we need to do that externally. Wouldn't make sense inside PHPP. So that's the first thing. So the calculation of the thermal performance of that detail is happening outside of it. And by this, we can then say, yeah, that's fine. We're staying above the 13 degrees in that corner. No problem, no mold problems. And as well, our thermal bridge value stays below the 0.01 watt,
Yeah.
0.01 Kelvin or watt meter Kelvin, depending on
Yeah.
what situation we have, point or linear. So that's the first thing. The other thing we haven't spoken about, and I think it's not even in the article, is you can have as well have a cold spot that leads to even a mold spot, not by a thermal bridge. But it is as well a thermal bridge, but it's not a traditional thermal bridge. It's an air leak. Yeah. So
Yes.
if you have an air leak, then you have as well the possibility that the temperature goes down because the thermal insulation is your woolly jumper. We spoke about that already. The woolly jumper that you're wearing on a windy day that is not doing anything. Soon the air goes through your woolly jumper, you're feeling cold. Yeah. And that happens when your airflow goes through thermal insulation. And then the performance of the thermal insulation goes down as well. So that's the reason a cold spot can as well happen by an air leak. Normally, when we do a blow-door test in a Passivhaus, we are avoiding that as well. If you're not doing a blow-door test, then obviously that chances are far higher. And the risk of mold on the surface is one thing. So that is the visual one that we are seeing. But then it as well can happen in the buildup because the air is now moving through, cooling down while moving through the buildup. And then on that surfaces in there, like your plasterboard, your membrane, your thermal insulation on the other side of the thermal insulation, and then your external membrane or something, on all the surfaces that are in there, condensation can then occur. And then we're having moisture buildup in the structure. And that actually then can cause mold growth in there and rot, and the integrity of the structure can be impacted as well. And that's as well happening when you may have a smelly room that smells like mold, but you can't see anything. Yeah.
That's when
If you
Daniel
can
comes
smell
in with
mold,
his
yeah,
fine
my
nose and
nose.
says,
Yeah, when my nose smells mold, there is mold, but it's not necessarily visible. It might be as well behind the plasterboard. Typical situation, as well in the designer course, we talk about it, is a poor installation of insulation on the inside of your
yeah,
structure. So in Europe, we often have a plasterboard with some insulation behind it. And what people do, they just put some mortar onto it, like dotting, and then they push it against it. what happens now? Your warm air gets into the top, gets behind behind the thermal insulation between the dots, moves down there, and while it moves down there, it cools down, and then we have condensation, and then we have full mushroom farms behind there, and it smells
Yeah.
like hell. Like, it doesn't need to smell, but it can, and that is, well, one of the typical situations. Good. I think we went through a lot of things now.
Yes.
That is
A
not
lot of
even in the
physics.
article, but I hope
Yeah.
that was helpful. Anything else to add, Julia?
Just want to say that, yeah, with Passivhaus, we are really actively thinking about these problems. We are eliminating our thermal bridges. We're making sure that our insulation is nice and continuous so that we're not creating these problems for your health, and that in the end, you get a home that is healthy and you can be sure that you're not breathing in all those mold spores that are really bad for you. So Passivhaus
Yeah.
really gives you that insurance that you're building a healthy home. If you're doing everything right, as Daniel explained, avoiding cold spots and ventilating right. And it has been proven for the last 30 years that passive houses are virtually mold free.
Passivhaus really helps you with the building regarding your health, the energy efficiency, the sustainability, and affordability at all as well, that we already discussed a little bit last week. Okay, thank you, Julia, and yeah, safe
Thanks,
travel,
Daniel.
and see you later in the
Thank
week.
you. See you back in Australia.
See you then. Bye.